Alright guys, today we are covering Chapter 1, Lesson 1.4, Properties of Real Numbers. Okay, and in this lesson there are going to be 5 properties that we are going to learn about, so go ahead and write 5 properties. Now these are all properties you've definitely seen before. Maybe you didn't know their name, but now we are going to give them a name. Okay, so our warm-up for today. A square picture has an area of 225 inches. What is the side length of the picture? The key here is that it says it's a square picture. So whenever there's a square, each side is the same length. To find the area, usually take the base of a rectangle times the height. In this case, for a square, it's the same side, so it's going to be s squared. So our area, we already know, is 225, which is equal to s squared. So all we have to do here is take the square root of both sides, and we get that s equals, the square root of 225 is 15 inches. So that is the side length of the picture. Simplify the expression, 7 plus 1 times 9. So for this one, we can go ahead and just put 7 plus 1. I'm going to rewrite it because it's a little blurry. 7 plus 1 is what we do first because obviously we have PEMDAS. Okay, so we're going to take care of that parentheses first. So we simplify it to 8. Sorry. How do I? Oh, there we go. 8 and then a 9 outside. Next we have exponents. There are no exponents. M, multiplication and division. That's where we multiply and we get 72. Okay, that was our warm-up. Should be feeling really good with math right now. And move on to the next slide. Equivalent expressions. So 2 algebraic expressions are equivalent expressions if they have the same value for all values of the variables. Basically, if it ever says equivalent, you know you're using an equal sign, okay? So that could mean a variety of different things. It could be A plus B equals C. As long as there's that equal sign, we are evaluating an algebraic expression that is equivalent to another one, okay? So A plus B is equivalent to C. All right, next we've got some vocab. So changing the order of the addends does not change the sum. Changing the order of the factors does not change the product. Take a look at this algebra box right here. There's a property here that's saying that A plus B equals B plus A and A times B equals B times A. This property is the commutative property. Okay, the commutative property. Now, what I like to do is I like to say A equals, let's say A equals 18, B equals 54. And we see that example right over here, okay? So 18 plus 54 is the same as 54 plus 18. They're going to be the same on both sides of that equal sign, okay? Both sides are 72, okay? Same thing for multiplication. If A was 12 and B was 1/2, this would be 6. And then even though you reverse it, it's still going to be 6, okay? 6 equals 6. Now, the commutative property, how do we remember this, Mr. Yurko? Well, by doing, I draw a nice big M, and I write reorder. Okay, so when we reorder something or an expression, we are using the commutative property. See how we reordered A plus B to be B plus A? When we are reordering, okay, think about McDonald's. At McDonald's drive-thru, you always have to reorder and reorder and reorder until they get it right. Think of that giant M, and we've got commutative, the double M in commutative, okay? It's a little tricky, but that's how I remember it. If that helps you, good. If it doesn't, you got to find another way. Next one. So for this next one, it is when we are changing the groups of the addends, we don't change the sum. So let's go ahead and take a look at the algebra. we've got a plus b plus c outside of parentheses is the same as a plus b plus c inside of parentheses. So we're just moving those parentheses around. That is called the associative property. Okay, it works as well for multiplication. So a times b with the c outside the parentheses is the same as a times b times c inside the parentheses. I know you might be wondering, but Mr. Yurko, don't you have to do the parentheses first? The only reason this works is because it's all multiplication. So if this was a plus b multiplied by c, that does not equal a plus b times c. See how we regrouped it where we moved the parentheses around the b and the c? This is not true. It has to be all the same operation. Okay, so let's take a look at our examples. We've got 23 plus 9 plus 4, that's equivalent to 23 plus 9 plus 4, and the same thing for multiplication. All right, how I remember this one? Associate different groupings. Okay, you associate with different groups, right? So when you're grouping something different, you're changing the association, so this is called the associative property. That's how I remember it. You don't have to remember it that way, but. All right, moving on. Let a be any real number. The sum of any real number and 0 is the original number. The product of any real number and 1 is the original number. So let's take a look at this algebra. A plus 0 equals a, and a times 1 equals a. This is called the identity property. Okay, the identity property, how I remember this one? If you start off with a, you add 0 or you multiply by 1, you are going to end up with a. It keeps its same identity. Moving on, so the product of a and 0 is 0. This is the 0 multiplication property. And that one's pretty easy. Anything times 0 equals 0. 18 times 0 equals 0. 7 times 0 equals 0. 1,000,000 times 0 equals 0. And lastly, this is the multiplication property of -1. Okay? And that just means that you change the sign. Okay, so we've got -1 times 9, that becomes -9. -1 times any number a is going to be equal to -a. So these are all of our properties for this lesson. Go ahead and get familiar with them. We will be using them to prove why certain things are the way that they are. All right, so let's move on to the next slide. What property is illustrated by each statement? 42 times 0 equals 0. Remember, multiplying by 0, that's the 0 multiplication property. I'm going to abbreviate property. And we've got y plus 2.5 plus 28 equals y plus 2.5 plus 28. Okay? This, where we regrouped, we associated different numbers with each other with parentheses. That's the associative property. Keep in mind, the only operation we had in here was addition. That is why we are able to regroup them. If there was any multiplication in there, we would not have been able to do that. Okay? And the next one, the last one for this page, 10x plus 0 equals 10x. I see 10x here, I see 10x here. We added 0 and we got the same answer. That's the identity property. Identity property. Okay? All right, got some more practice. So 4x times 1 equals 4x. Same thing, we had 4x, all we did was multiply by 1, which is also the identity property. okay? And now we've got x plus, in parentheses, square root of y plus z equals x plus, in parentheses, z plus the square root of y. Now you might be thinking, oh, it's got these parentheses, it has to be associative. This is a tricky one, okay? We did not change what was inside the parentheses. It's still the square root of y, and it's still z, right? Z is over here, square root of y is over here. But what we did do was we reordered them, okay? See how the z comes first in the parentheses now? It went from coming second, actually last in our expression, to now in the middle after x, okay? This is called the commutative, okay? Remember, if we are reordering, we're reordering at McDonald's, that M, those double M's right here, okay? That is where we get our commutative property. All right, so sometimes when we are doing mental math, this helps a lot. So let's take a movie ticket costs $7.75, a drink costs $2.40, and popcorn costs $1.25. What is the total cost for a ticket, a drink, and a popcorn? So total cost, we got to add all these up. So $7.75 plus $2.40 plus $1.25. Now, what we have to do is we have to, if we were doing this all in our head, okay, we would want to combine the things that are similar, right? Now, I immediately would think to combine these two, because if you have a quarter and a dollar and you add that with $7.75, you're going to end up with a whole dollar, because this 75 plus 25 will give us 100. So how we do this in math is we use the commutative property to rewrite this as 775 plus 125 plus 240. I forgot my dollar sign. There we go. Okay? And then we associate them with each other. Okay? And now we can combine what's inside the parentheses to give us a whole $9 even, plus $2.40, which then we can mentally do as $11.40. Okay, so some of us do this naturally, but now we are giving names to what's going on in our heads. Super cool. Okay, so using properties to simplify expressions. So we've got 5 outside the parentheses times 3n. So this 3n we can no longer solve. We have all multiplication. So yes, we can use the associative property. To shift those parentheses around. So we're going to put 5 and the 3 inside the parentheses, the n outside. 5 and 3 we can multiply together, unlike 3 and n. So now we can get that this equals 15n. Oops, that was a terrible box. 15n. Okay, next we've got 4 plus 7b plus 8. Now this one we're going to use 2 properties. We're going to go ahead and use the commutative. To mix this up and write 7b plus 4 inside the parentheses plus 8. That way we put the 4 and the 8 next to each other. So all we have to do is regroup it using the associative property. If I could spell. And it's going to be 7b outside the parentheses, 4 plus 8, which is 7b plus 12. And that is our simplified answer. All right, and the last one. This one's fun, okay? So we've got 6xy on the top and y on the bottom. Everyone can just go, oh, we get rid of the y's and we're left with 6x. You are not wrong, but in this lesson, we're learning how to describe what we're doing. So you would be wrong if you did that on a test or a quiz, okay? for this lesson. So what we're going to do is we're going to separate everything. And we've got y on the bottom. Now, what we're going to use is the identity property. And we're going to say that y is the same as y times 1. Okay? So now we're left with 6x, which we can put over the 1, times y over y. You might be wondering, Miss Jericho, why were you able to do that? Because if we have 6x over 1 times y over y, when you multiply fractions, you multiply straight across, right? So this becomes 6xy on the top, and this becomes just y on the bottom. That's exactly what we started with. Okay? So when we break it up like this, now we can say that the 6x divided by 1 just is 6x times, and then y time over y is y divided by y, which is just 1. So now we have 6x, which is our answer. All right, cool. Next, simplify each expression. So we've got 2.1 times 4.5x. Let's go ahead and use associative. And let's change how this looks. 2.1 times 4.5x. Okay. Now we're going to be left with 9.45x. Good. And next one. So same thing, we're going to use commutative. So we're going to have 6 plus, instead of 4h, we're going to put 3 first. And then we're going to use the associative property. And we're going to put 6 plus 3 inside the parentheses and plus 4h. And now we've got 9 plus 4h. Okay? And the last one. So for this one, we're going to break everything up. It's going to be 2 times 4 times m over 2 times, 3 times 4, because 12 can be broken up into 3 times 4, times m times n. Now we can look to cancel stuff. So we've got this 4m, which is common, over 4m. And no, we've also got times 2 left on top, over. We've got a 3 left over and an n left over. This is going to cancel to give us 1 by the identity property. So now we're left with 2 over 3n. Okay? And deductive reasoning, that is but what we've been using. We've been using logical explanations, and we give facts from given facts to lead to a conclusion. So we've been given the associative property, the commutative property, and the identity property in order to reach conclusions. So an example showing that a statement is false is called a counterexample, and you only need one counterexample to prove that any statement is false. Go ahead and get this copy down, and we are going to do some examples. So for the first one, we want to find out if this statement is true or false. If it's false, we need to give a counterexample. So it says, for all real numbers a and b, a times b is equal to b plus a. That doesn't seem right. So let's go ahead and just try one out. A equals 2, b equals 3. So let's say a times b is going to be 2 times 3, which is 6. This should be equal to b plus a, which is 3 plus 2, which is 5. So this is saying that 6 should be equal to 5. That is not good. And this is our counterexample, okay? Next one, for all real numbers a, b, and c, a plus b plus c equals b plus a plus c. We can say let's start with a plus b plus c. How can we make this look like b plus a plus c? Well, first we can use the commutative property. to reorder things around. So in our second portion, it says that B comes first. Let's go ahead and put B first. And then next, it regroups, so it has A and C in parentheses. That would be using the associative. So this would be then B plus A plus C, which is exactly what we wanted. So using our, we can say that this is true, using our properties that we just learned. And this one was false, sorry. You should gather that it was false by the X, but we'll write it in there anyway. And next one, we're on homework. So that was the lesson for today. Here's your homework problems. Go ahead and get those done with. And yeah, hopefully I'll see you guys tomorrow, and have a great day.